In these first two examples, we're just going to explore the effects of the parameters a and b on an exponential function. So we know that the general form of an exponential function is a b to the x, right? And so what we're doing in example 1, you can see that the only thing that's varying is b, right? In example 2, we're going to vary a. But the question is asking us to graph these exponential functions. So I went ahead and did it for you because it's kind of boring. You don't need to watch me do all these calculations and plot points. I'm sure you can do that on your own. So all I've done is taken values of x and plugged them into each of the equations and plotted them over here. So you can see that in the first equation, we've got a growth factor b of 0.8, so we have exponential decay, and you can see that we have a decreasing function. That's the green line. And then for the second equation, we've got a growth factor of 1.3. So that's b, and it's exponential growth, and you can see that graph in the red line. And the blue line has a growth factor of 1.5. So it's growing faster. It's growing by 50% each time. And you can see that what's happening with that graph. So we're looking at the effect of the parameter b, and you can see that if it's less than 1, you get decay. If it's greater than 1, you get growth. And the bigger that the b value is, then the faster it grows. So in the second example, we're looking at the effect of the parameter a, which is the initial amount. I should point out too, notice that all of those graphs in example 1 pass through the point 2 when x is equal to 0. And in the second example, we're looking at the effect of the parameter a. So you know that in this first example, this is 1.3 to the x times 1. So essentially our a value, a is equal to 1. And then we have a equals 2 and a equals 3. And a equals 3. And so we're just looking at how that affects the graph of the function. So again, I've just put in values for x and calculated values of the function. And you can see that and we've said this before, that a is the initial value, so it's the value when, this should be x is equal to 0, and so you can see it just moves the y-intercept up. We could put in a negative value, we'd get a negative y-intercept. And then we've got a constant b value, so they're all growing at roughly the same rate, but the initial value is greater in as you increase a. Okay, so what's more interesting, I want to just take a moment here to, you can do this in Desmos, and it's kind of nice. So let me bring this up. Hopefully that'll show up well for you. Let me see if I can move this over. Well, no, I think that's probably good enough. All right, so here's Desmos. So I've put in the function y equals a b to the x. Right? And right now, a is 1 and b is 1. So it looks kind of boring. It's just 1 times 1 to the x power, which is just 1. So, you know, in the first example, we looked at b, and so you can look at the effect of the growth factor. And so if I increase b, you can see that it starts growing, right? You can see how b affects the parameter. So these are b values greater than 1, so you get exponential growth. So if I go back to 1, and now I go below 1, right? So 1, we get the straight line just because and then here, if b is below 1, then we get exponential decay. And you can see that a is 1, so it's always passing through 1 when x is equal to 0. Okay, so a b value of 1 is pretty boring. That's always going to be a flat line because 1 to the x power is always 1. So let's just set this to like 1.5. There we go. And let's look at the parameter a. What does that do to it? I'm going to vary a, and you can see that it just affects the y-intercept, right? It's a multiplier, and it's just multiplying the function times times a. We're multiplying b to the x times a, and so you can see that b to the 0 is always 1, so the y-intercept is always equal to whatever a is. Okay? And it works the same if we go back to exponential decay. Let's look at an exponential decay, and it does the same thing. It just affects the y-intercept. All right. So, all right, let me get rid of that. Let's go back to let's kind of summarize what we just talked about. So if we have the general form of an exponential is a b to the x, then a tells us the y-intercept. If b is greater than 1, we have exponential growth, and the growth rate is b minus 1. And we have a positive growth rate if b is greater than 1. If b is between 0 and 1, we have exponential decay, and the growth rate is negative. All right, so I will, that's the first two examples. I'll meet you for example 3 in the next video.